Swayam Prabha. Digital India. Educated India.
Welcome back to Mechanics and Control of Robotic Manipulator. The last lecture we stopped a few example left over. So I thought before that I thought of giving the cases, different cases how to attempt. So based on that now we will come back to this examples. So these examples. So we will start with one of the classical example what you call two are parallel and one prismatic also parallel. So now there may be a question will come. So what would be the nature of this? So this is also like going to swept in a volume, because this is going to rotate in a plane, but this actually like make it what you can say up and down. So what we did in articulated very similar, but here the workspace would be more like a donut, and that too like you can actually like make it, it is not really a donut, it is something like a you can say a hollow cylinder kind of thing, it would be obtainable based on the limits. So but now what we really wanted to see here, so we will try to find out the frame arrangement and then we can see what would be the end effector position with respect to your base. So that is what we are interested. So if we are actually like seeing this interest, what one can see, so we can actually like fix always the z axis. So this is z1 and this is actually like z2 based on given, and the based on this the positive direction is given here. Okay. So please be clear. So this is the positive direction of this. So now what one can see, so these all are parallel. So now we can take conveniently where you want to start what so called the frame starting point. So we know like conveniently we start, this is actually like a 0 and we take it z0 also parallel, right, and now I am taking the convenient as the last point as 4, this is actually like pointing downward as the fourth axis, right. So now what else we need to do, so we need to fix the frame 1, 2, 3. As we already seen the frame 1, 2, 3 we can conveniently take as per our interest. So now I am taking, this is actually like 1 and this point I am taking as 2 and this point actually like it is moving, right. So obviously we can actually like see where it is actually like moving. So on this line, so the end we have to actually like fix it. Okay. So now we can actually like take it here, this is actually like 0 d3. So we assume, so now this is actually like what you call the frame 3, and now you can see like what, this is a some constant length we call d4, okay, this point to this point, and this distance what you call, this is between 2 and 3. So this is a3, sorry a2, and this is between 1 and 2, this is a1, right, and this distance is actually like again d1, right. So I am actually like for your benefit I am just drawing this diagram here. Okay. So here I am actually like drawing it for your convenient. So what we can actually like see, so I started this as 0 and this as actually like 1 and this actually like as a 2 and this as actually like a 3 and this as 4, right. So now in that sense what we can actually like see, this is what z0, this is actually like z1 and this is z2 and this is z3, this is actually like a distance variable, d3 is variable, in this case theta 2 variable and this case theta 1 is variable, and this case I took it as opposite direction. Okay. So now what else, next case, so next case is actually like you have to fix the x axis, right. So for fixing x axis what one supposed to see, so you have to see the for example you want to fix x0, you have to see what is the nature of z1 and z0. So in this case all axes are parallel except z3 and z4 are actually like you can see these two are actually like opposite directions, still these two are parallel. So in the sense what one can do, so you can take any convenient normal axis, you can see either you can take this as x or this as x or this as x or this can be x, that is sufficient. In the sense, you can actually like take anything on the plane, you can actually like take it, but you know there is two distance coming. So, I am taking this along the x direction. So, in the sense, what we are actually like doing it. So, we are actually like doing it as, so I am taking in this way. So, this is x0 and this is x1 and this is x2 and this is x3 and this is x4. Okay. So, in that case, what would be the DH parameter? So, DH parameter in this case, so no rotation except this point. So, in the sense alpha, you can say 4 minus 3, which is actually like 3, which is 180 degree. So, remaining all the case alpha 2 is 0, alpha 1 is 0 and alpha 0 is 0, right. And when you talk about the, you can say the A distance. So, A0 is 0 and A1 is this, right. This is A2 and A3 is 0, right. So, then what else you need to see? So, the theta 1 it is exists, which is a variable. This is 0 plus theta 1, this is 0 plus theta 2. The third one is, so there is 0, okay, because there is no active, and the fourth one again 0 because the x3 and x4 with respect to z4 are parallel, right. So, when coming to the distance, so 0 to 1 there is a distance, that is d1, 1 to 2 there is no distance, so d2 is 0. So, 2 to 3 there is no distance along z3, that is 0. So, d3 is 0 and here there is a distance. So, you can say 2 to 3 it is 0, but 3 to 4 there is a distance, that is what you call d4, that is the positive direction. But in addition to that, what happened, this 2 to 3 there is a d3 which is a variable like this, right. The sense you have to write 0 plus d3. Okay. So, in order to make it easiest, so what I made it, so in order to make it convenient for you, I made a frame arrangement in such a way that what I did actually like this is opposite direction. Okay. So, in the sense I assume that this is the positive direction which is coming downward. So, that frame arrangement I made it here. Okay. So, you can see if that is the case, this final point I can take it as a 3. So, you can see we have taken a normal way that actually like take 4 frame, but now I actually like simplified. So, that's why I said although this is the positive direction, so what I can do, so whenever I substitute d3 I can substitute as minus, right. When I substitute in the actuator end, when I am trying to control, I can put it as that is opposite direction, that is easiest for me. So, this is what the experience, and now you can see like whatever else we have done. So, the same thing we did, but even then you can see one additional thing also I make it just for your clarity. So, what I did, I started 0 and 1 here. So, this is z1 and 0 and this is z2 and this point is actually like z3. This distance is d3 variable and this is a2 and this is a1 and this distance is actually like d2. Okay. So, that is what you can see, right, because 1 to 2 I am actually like looking at a vertical distance. So, that is why you can see the frame can be arranged in two ways, either this side or you can actually like do it this way. So, both are finally at the end giving the same result. So, we can check that. So, how we can do check? So, we can find first DH parameter. So, in this case the DH parameter in this form. So, what one can do? You can actually like substitute that into transformation matrices. So, now you will get 3 transformation matrices and you multiply, post multiply one another, right. So, finally, what you will get, the transformation matrix of 3 with respect to 0 you will get. So, what would be the final end? This. So, now you go back, just for understanding, you go back, what is your home position? So, home position is theta 1 is 0 and theta 2 is 0 and d3 as it is, right. In the sense, what would be the x, you can say 4 with respect to x0, that would be a1 plus a2. What would be y4 with respect to y0, that would be, or you can say the fourth, or you can say sorry, third frame. The third frame with respect to 0 is x axis, it is a1 plus a2 distance, y axis it is 0 distance and z axis it is d2 minus d3, right. This is opposite direction. Whether we are getting that or not, we will check it. So, what we can do, you put theta 1 and 2 are actually like 0 degree. If I write this way, this is equivalent to theta 1 plus theta 2. If I write 1 hyphen 2, which means theta 1, okay, minus theta 2. Okay, that is the idea. Okay. So, I hope now you are actually like clear. So, in the sense this is cos theta 1 plus theta 2. So, theta 1 and theta 2 0 means this become 1, this becomes 0, this become minus 1, this becomes 0, and this become 1, this become 1. So, a1 plus a2 exists, and this becomes 0, this becomes 0, then this whole term would be 0, and this is actually like exists, right. So, further what you need to do, you need to check. So, what one can see, the z3 is coming and z0 is actually like upward direction. Further everything is actually like, you can say this is x3 and this is x0. As per the right hand rule, this is your y0 and this is what y3. In the sense what one can see, the rotation matrix of 3 with respect to 0 by projecting x0 projection like this. So, y3 projection on 0 is actually like 0 minus 1 0, and z3 projection is 0 0 minus 1. You get that also, right. So, in the sense whether you use what kind of you can say DH parameter, finally if you get this end product is as per your understanding and original way. So, then this is what we call or you can say true or actually like correct DH parameters. Okay. So, now we will actually like go one additional example. Okay. So, what we can do, this is actually like RRP, in the sense it is very similar to you can actually like see several of us would be having it. So, in the sense the first rotary here, the second rotary, and the third vertical is actually like going in and out. So, in the sense this make a, you can say, spherical workspace. So, that is what we are actually like calling as a spherical manipulator. So, in this case it is very straightforward, because this half we have already seen and this is the only additional part, so which we can see. So, now this is Z3 and this is actually like Z2 and this is actually like Z1. So, in the sense what we can do, so we can actually like see this is 0 and this is 1 and 2 and you can see this is 3. So, further what we can see, this is actually like a Z3 and this is Z2 and this is Z1 and this is Z0. So, x0 is actually like fixing with respect to Z1 and Z0. These two are parallel and these two are the plane containing the progressing side. So, this is what you call x1, but while choosing x2, what would be the case? You have to check Z3 and Z2 nature. The plane containing is this, right. So, in that sense what would be the direction? It should be up or down. So, I am taking this is actually like x2 direction. So, obviously then x3 I can keep it like this. Okay. So, now this is the way we can actually like fix the frame. I hope I have done that. No. So, I have actually like what I did, I have actually like modified. This is one way you can do it. The other way what we can actually like try to do it. So, I am actually trying to show. So, you can actually like see, you rotate this. So, if you rotate this, because this is theta 2 is active, right. If you rotate this, what happens? This is 0 frame, okay. This is 1 and 2 and this is actually like 3, where this would be still Z3 and this is Z1 and this is Z2 and this is Z0. So, in that case what is the benefit? You can fix x0, x1 and 2 and x3. So, this is based on the experience. Now, you can see this is, so D1, okay, and this is D3 and this is theta 2 and this is theta 1. These are the variable, right. So, that is the frame arrangement which we did here, right. So, there are two, you can say twist angle will come. So, one is actually like between 1 and 2. So, the second one is actually like between 2 and 3. So, one would be actually like 270 degree rotation, the other one is actually like you can see. So, the other one is actually like 90 degree rotation, that is all. Okay. So, now we can actually like cross check whether whatever we obtained, that DH parameter is giving the right result or not. So, for that what one can do, we can first find the DH parameter. So, we can actually like see this is the way the DH parameter we have obtained. So, based on the obtained DH parameter, we can actually like find the final transformation matrix, right. So, now we can substitute theta 1 equal to 0, theta 2 is actually like you have to see in this case 0. So, theta 3 is actually like 0 based on the home position. So, in that sense what one can see, so this become 1, this become actually like 0, this 0. So, this becomes 0, this also becomes 0, this is already 0, this is combination 0, this is actually like combination 0, this is 1, and this become actually like 0, this also becomes 0, this remain D1 plus D3, right. So, you would have recall what we did. So, we have actually like taken this way, right. So, this is Z3 and this is Z0, and I am actually like drawing this is X0 and this is X3, and this distance is D1 and this distance is D3, and this is 1 and 2. So, if you are looking at the third frame projected on 0, so what are the things? So, the x axis it is parallel, so 1 0 0, right. So, Z3 also parallel, in that sense the right hand rule if you take, this is the Y3 and this is Y0, so 0 1 0. So, you can see this is 1, okay. So, then the third one is 0 0 1, and what would come the other way around. So, the x axis displacement you can see 0 and 1, there is no displacement, 0, that is we cross checked, y also there is no displacement, and z axis D1 plus D3. The sense this matrix is actually like correct, right. However, if you want to actually like cross check this configuration, so this configuration you want to check, so then what would be the theta 2? So, theta 2 you have actually like rotated, right. So, in the sense theta 2 supposed to be 90 degree. So, then only you will get, in that sense what would be the x displacement would be D3. So, y displacement would be 0 and z displacement would be so D1, and the rotation matrix, so it would be, so you can actually like see what we fix. So, this is what we put x3. So, in the sense x3 is on the z0, so 0 0 1, okay. So, the second one is actually like coming back. So, what would be this? So, this is what y3 comes here, but here this is opposite. So, 0 minus 1 0. So, the third one is actually like 1 0 0, right. So, we will cross check that is obtainable here. So, by substituting that, so you put theta 1 is 0, but theta 2 is actually like 90 degree. So, in this case this becomes 0, right. So, this become actually like what you call, this become 0, and positive rotation or negative rotation you have to see. So, what we have taken, this is the direction and we have actually like taken that. So, I will actually like cross check that. So, where is that? So, we have actually like rotated this way. So, in the sense, so this is the direction, so that is coming. So, in that sense you can see there is a minus 1 comes here. So, then here also minus 1 comes, and sorry, this is 0, this is actually like 0, sorry, this is 1, and here you can actually like look at it, the combination is giving 1 and this 0 and 0, and this is actually like you can see this is 1 and this is also 1, D3 exists, and here this becomes 0, the D1 is exists, right. So, in the sense that is also we have cross checked and it is actually like happening. So, now we will move one more example, which is actually like we have seen two prismatic joint, which is we call cylindrical, which is one of the easiest one which you would have realized, because most of you would have definitely gone through what you call the you can say workshop practice, where you would have seen the cylindrical drilling machine. So, the cylindrical drilling machine is actually like in this configuration. So, where you can actually like roll, first thing is actually like you can rotate the arm, then you can move up and down, and then you can actually translate to and fro. So, that is what the whole idea here. So, here you can see like this is the first rotation, then the translation, finally translation. In the sense what you can fix, so here you can fix 0 and 1, and the end tip you can put 2 because the intersecting, and the last point you can put 3. So, in the sense what you can draw it is easiest. So, this is 0 and 1, and this is 2, and this point is 3. This is D3 and this entire thing is D2, and here actually like rotation is theta 1. Okay. So, that is what we have done, you can see, right. So, now x axis you can fix it either way. So, I choose an x axis which is coming outward, Okay. So I can actually like see it everywhere. It is actually like coming outward. So that is actually like a benefit. Why? Because I don't need to change the orientation of the x axis. So that is what the case. But if I actually like do the other way around, what happened if I would have started here as x, so then there would be a change and I cannot keep it here. But if I choose this x parallel everywhere, either it is going in or out, so both are actually like going to make sense. For me, all the time I put in, so this case I have taken out, right. So now what would be the standard? So the theta 1 would be 0 is the home position. In that sense, the x axis displacement is d3, y axis displacement is 0 and z axis displacement is d2, right. And the orientation is actually like what? So the orientation is 1 0 0, right. So then that second one would be, you can see like 0 0 minus 1, the other one is actually like, sorry, so I will use it here. So what this? So the x3 projected on, you can say 0, so that is parallel to this, so 1 0 0, okay. So in this case this is y 0 and you can see y 0, this case means what you will get, this is what y 3. So y 3 is actually like parallel to z 0, but it is opposite, so 0 0 minus 1, and z 3 is parallel to y 0, so 0 1 0, okay. So these all we can actually like check whether your DH parameter is giving the same way. So we can actually like find that, sorry. So this is the case. So you can see like if you put theta 1 as 0, this become 1, this becomes 0, this becomes 0 and this become 1, and this become, you can say 0, right. This become actually like d3 and this become d2. So we made a small mistake there, so please correct it, because conventionally we took it. So you can see this is the displacement which is actually like d3, that's supposed to be in y axis because we take x this way, right. So this is y and this is x and this is z. So I hope now you are actually like clear. So that's why there is a swap, okay. So now you can see this is what happening, right. So y d3 and this is z and this is 0, okay. So with that you are actually like clear. So one last attempt we make and then close this particular lecture. So what is that? So it is a Cartesian. For fixing Cartesian you have to play a small clever rule. So what small clever rule? So although you start from the base here, but the first joint is going like this. So for our benefit we can start the base here and this distance we can cover it later on. Otherwise we have to start a passive joint here, okay. So I am actually like starting here like this, okay. So in the sense this is 0 and this is 1 and this is 2 and this is 3. So this is D1 covered, this is D2 cover and this is D3 cover. So now what would be the joint axis? This is actually like, I put it probably I put it this way. So this is Z0, okay, and this is actually like Z1 and this is actually like Z2 and this is Z3. So then x axis, obviously the plane containing perpendicular to that. So this is x0 and here the plane containing either you can go up or down. So this is x1 and in this case either you can come outward or inward. So this is x2 and I can actually like make it parallel to this as x3, okay. So now we can actually like see that in a pictorial. So you can see like this is what we have taken. So x1 we put it downward and x2 is actually like inward. That's the configuration we did. So now I hope I left this as an exercise. You find the DH parameter and cross check whether you are getting the same DH parameter what I am getting it. So you substitute that, okay. You substitute that, finally you will get this. So what one supposed to actually like feel it. So this matrix need to be cross checked. So what we did, so this is Z0 and this is actually like a Z1 and this is actually like a Z2 and this is actually like, this point is actually like Z3. So D1, D2 and D3 and this is X0, right. So now based on this configuration, so what one can actually like see, So obviously the x displacement along x0 is d2, that is coming. So along y the d1, that is coming. Along z it is opposite direction, d3 minus d3, that is coming. So the position vector side it is true. So coming to the orientation side, this is x3 parallel to x0, so 1 0 0, and y3 is actually like opposite to y0, so 0 minus 1 0, and z3 is actually like opposite to z0, 0 0 minus 1, right. So in the sense what we did, we have actually like found everything is in actually like order, and you have actually like obtained the right, you can say, transformation matrix and right DH parameter. Now you are actually like ready to fly for forward kinematics and then inverse kinematics, everything. Even you can go further on kinematic control through differential kinematics. So what we have done very simple. So we have started with the DH representation. The DH representation is full of DH parameter. We have taken few example. Even this example we have taken few cases, and then we have taken this example. I hope now you are clear about how to fix the frame and how to actually like arrange it, how to calculate it. Okay. So with that I am closing this particular lecture, and see you then with the forward kinematics in the upcoming lecture. Thank you.